All right, guys, we are going to take a look at the next section about solving literal equations. Basically, the idea here is that we're going to be able to create equations to solve problems, and we can also rearrange different formulas by using properties of solving equations in order to isolate a variable. So you'll see those two objectives there at the top of the note sheet. So we're just going to start diving into a few examples. The first example says Nora drew a rectangle, and then she drew the length of each side from end to end to make a line segment to represent the perimeter. So remember, perimeter is the distance around the whole figure. So here's her rectangle, and then she just copied the length segment in blue here, and then she put a width segment next to it. Same thing with the other length and other width. So what we want to do is we want to use this diagram to write an equation that represents the perimeter of this model. Well, if you remember, perimeter is going to be the distance around the figure. So it's all the side lengths added together. So we're basically going to take the length plus the width plus the length plus the width. That's it. Literally, we just wrote an equation to represent perimeter. We don't need to do anything else. We've just incorporated all four sides here and added them all together. Part B says rearrange the order of the sides so that you can represent the perimeter with a different equation. Okay, so basically, this is where we're going to get into rearranging variables. I can add different numbers or variables in any order. So I could maybe put the two lengths together and then put the two widths at the end. Maybe I do the widths first and then the two lengths. Maybe I do width, length, width, length. Any order you want to add them in, doesn't matter. They'll always be the same. It says, is this equation equivalent to the equation in part A? Yes, it would be, because we're just adding two lengths and two widths together, which is the same thing I have here. I have two lengths and two widths. Okay, so just an idea of what I mean when I say we want to be able to create an equation. If I give you a model of something, we want to be able to use that model to come up with an equation that we could use if we wanted to solve a problem regarding perimeter in this case. Example 2, we're going to start talking about this deals with interest. So it says Janet wants to calculate the time it'll take to earn a certain amount of interest on a principal amount in an investment with simple interest. So it says use the simple interest formula, I equals PRT, and solve for T. So basically, interest is money you earn from a bank account. Okay, so let's say I deposit $100 in a bank account and there's 5% interest annually. That means at the end of the first year, if I don't touch that $100, I'll have $105 in that account because I'll have made 5% simple interest. So interest is just money that you can earn literally for doing nothing just by having your money sit in a bank account. So it's always a good idea to research when you open bank accounts which have the best interest rates. So this is just a formula that'll help her calculate how much interest or how much money she'll earn off of her principal amount. So principal amount, that means your starting amount. That's how much money you put in at the beginning. Okay, so the money you invest or you deposit in your account at the beginning, like when I first started with my $100, that would be my principal amount. That's the amount of money I'm starting with. Okay, so basically, if I take this equation, I equals P, which is for principal, R is for your interest rate. So like if it's 5%, my rate would be like 0.05 times time. And that just means like how many years I'm going to be investing my money. And then I stands for interest. So we call this a literal equation. So it's a literal equation because it has multiple variables that represent a bunch of different information, and we can plug in for those different variables the information that we're given. If we're not given that information, we're going to leave those variables there. This problem, I didn't give you any information to plug in. The directions just say solve for T. So basically, we want to get T by itself. So we're going to use the properties of solving equations like we have been to get this T variable by itself. So since the equation is I equals P times R times T, and we want to get T by itself, to undo the P times the R, we're going to divide both sides by P and R. So since it's being multiplied, P times R times T, we can actually divide by P and R both at the same time because it's all multiplication. So when I do that, P divided by P is a 1 that goes away. R divided by R is a 1 that goes away. And we're just left with T by itself there, which is our goal. We want to solve for T. On the left-hand side, we have a I for our interest divided by P times R. Well, since none of those are the same variable, none of those are like terms, we are done there. We're just going to leave it as I divided by P over R. So I would take the interest rate, I would divide by the principal times the rate, and that would tell me how many years it's going to take for her to earn a certain amount on her account. Okay, so the main idea here is to take a variable from a literal equation and be able to isolate it or get it by itself. Okay, so same thing here for number 3. It says Rob is an electrical engineer who works with a lot of wires. He needs to calculate the length of a wire using the resistance and the resistivity and the area of the wire. So like all this information that I know nothing about, but the electrical resistance formula is R equals P times L all divided by A. Okay, so basically it just says solve the literal equation to find the length of the wire. So the length of the wire, that was the L in the formula. So we're going to solve for L. Okay, so again, I don't know anything about electrical engineering. Okay, my brother's an electrical engineer. He would probably think this problem makes perfect sense, but I know nothing about it. But I do know how to solve literal equations. So I'm just going to do the math part. I don't understand the concept, but that's okay. I'm just trying to get the L by itself, basically. So the things that are happening around the L here, we have P times L divided by A, okay? So what we want to do is we want to get rid of this fraction first, okay? So since I want to get rid of this fraction, since it says P times L divided by A, I'm going to undo dividing by A with times A. Well, if I do times A on the right, I have to do times A on the left. So A divided by A goes away, and I'm left with P times L. And then on the left-hand side, I have A times R. Well, A times R, those are not like terms, so I can't really do anything with that, so I'm just going to leave it. So then to get the L by itself, remember we're solving for L, this says P times L. So to undo multiplication, I'm going to divide. So if I want to get rid of the P, I need to divide by P here. If I do it on one side, I have to do it on the other. So P divided by P goes away, gives me a 1. So I'm left with a 1L or just an L. And then on the left, I have A times R all over P. And I'm going to leave it just like that because I have no idea what any of those values are. I can't plug in for them. And they're not like terms, so there's no simplifying I can do. So we're literally just rearranging where the variables go. We're not doing any simplifying. So it's actually kind of easy because you're just moving stuff around. So on the second part of the notes, I just have some actual just practice equations. It says solve each literal equation for the indicated variable. So this is just to get us to practice using that skill of rearranging formulas. So this says B divided by C equals A. And then it says solve for the indicated variable. This means we're going to solve for C because it's after the semicolon. So this means we're going to solve for C. We're going to get that C by itself. Okay, so I'm going to rewrite it. It's B divided by C equals A. And we want to get the C by itself. Well, the problem here is that B is being divided by C. C is in the bottom of the fraction. So to get rid of it, we are going to multiply by C. Okay, well, if I do it on one side, I have to do it on the other. So C divided by C goes away, and I'm just left with B right here on the left. And then A times C is just going to stay A times C because you can't combine them in any way. They are just separate variables. They're not like terms. Okay, so I just rewrote it over here so I have some more room. So remember, we want to get the C by itself. So I have A times C. So to undo A times C, I'm going to divide by A. Well, if I divide by A on the right, I have to divide by A on the left. A divided by A gives me a 1C, or just a C. And then B divided by A is just going to stay B divided by A. Again, we don't combine anything there. They are not like terms. So if we want to get C by itself, we're going to say C equals B over A, or B divided by A. So I want you guys to go ahead and take a shot at number 5. D, F, G equals H. So that says D times F times G equals H. And you're going to solve for F. So you're going to get the F by itself. So go ahead and pause the video. And then when you finish the problem, go ahead and resume the video so you can check your work. So hopefully you were able to come up with F equals H divided by DG. So since it was D times F times G, and I wanted to get rid of everything around the F, I divided by D and G to get those to go away. Okay. So let's take a look at number 6, and then I think you can probably try the rest on your own. So number 6 says 2x plus 3y equals 12. So this one's a little bit different because there's some numbers in here now, but the process is still going to be the same. So we want to solve for y here, so which means we want to get the y by itself. So in order to do that, I'm going to draw my line down there. I want to go ahead and start. I'm going to keep the y where it is because that's what I'm solving for, and I'm going to get rid of this 2x. So because it's a positive 2x, I'm going to minus 2x on the left. Well, if I do it on the left, I also have to do it on the right. So the 2x's are going to go away. That's just 0. And we're left with 3y here. That's just going to stay. Here I have 12 minus 2x. Well, since this is a 12 and this has a variable with it, those are not like terms. They can't be combined. So I'm literally just going to keep it as 12 minus 2x. I cannot combine those two terms because one has an x and one is just a number. Those are not like terms. To separate the 3 times y, since it's multiplication, we're going to undo that by dividing by 3. So when I divide by 3 here, I have to divide this whole side by 3 on the right. So 3 divided by 3 is a 1y, or just a y. That's gonna, the 3's are going to go away. And then here we have 12 minus 2x all divided by 3. So this, we would look at the 12 and the 2, and we would say, do both of those numbers divide by 3? Well, 12 divides by 3, but 2 does not. That would be a decimal. So because they don't all divide by 3 on the top, we're just going to leave it as 12 minus 2x all divided by 3. Okay. I would say you guys could try number 7 on your own. I'm going to skip that one and I'm going to do number 8, and then I'll have you go back and try 7 after I finish number 8. So number 8, this is the volume of a cone formula. The volume of a cone is 1/3 pi times the radius squared times the height. So to solve for h here, it means I want to get the h by itself. We have v equals, I'm just going to rewrite it so I have some room, 1/3 pi times r squared times h. So if I want to get the h by itself, I'm going to leave it there. I want to get rid of everything around the h. Now, since it's all multiplication, we could go ahead and divide by all of these pieces at one time. But instead of dividing by this 1/3, since 1/3 is a fraction, we don't like to divide by fractions. In order to get rid of a fraction, we're going to multiply by the reciprocal. So remember, the reciprocal means you just flip your fraction upside down. So the reciprocal of 1/3 is 3 over 1. So if I multiply by 3 over 1 on the right, I'm also going to multiply by 3 over 1 on the left. Okay, so 1/3 times 3 over 1, that's going to give me a 1. Those are going to cancel. Okay, so if you think about that, 1/3 times 3 over 1, 1 times 3 is 3, 3 times 1 is 3, 3 divided by 3 is 1. So that's why that works, okay? So 1 over 3 times 3 over 1 is going to go away. And 3 over 1 is just 3 times v. So that's just 3v. 3 times v just stays 3v. Then we have pi times r squared times h. So again, those are all being multiplied. And now that we just have variables left, I mean, pi is not really a variable, it's a number, but we're going to use the pi symbol to represent it. We can just divide. So in order to get rid of the pi and the r squared, since they're all being multiplied by h, that's what we're going to divide by. We're going to divide by pi and r squared on the right. And if I do it on the right, I have to do it on the left. So pi divided by pi is 1, goes away. R squared divided by r squared is a 1. It goes away, and we're just going to be left with an h. So on the left, we have 3 times v on the top, divided by pi r squared on the bottom. And again, I have no like terms, so it's going to stay just like that. 3v divided by pi r squared. Okay. So hopefully that was a good enough, that was a good number of examples for you to solve a literal equation. Go ahead and try number 7. That'll be the last one. Pause the video and try it, and then resume to see if you got it correct. And then we'll be able to go over questions in class. So hopefully you were able to come up with x equals 12a all over 10. One of the things I want to make sure I mention is this would not be my final answer, only because 12 and 10 can be reduced. So both of those divide by 2. So 12 divided by 2 would give me a 6, and then I would just leave the a there. And then 10 divided by 2 would give me a 5. So it would be x equals 6a over 5. Okay, so hopefully you were able to get that one correct. If you have any questions on solving literal equations, please make sure you ask in class this week. So we should have plenty of time to go over any of your questions. Good luck.